Let f is a function from r square to r defined by this structure. At the point 0, 0, which of the following statement is are true? F is continuous. F is continuous. Sorry, first option is f is not continuous. Second option is continuous. F is differentiable. Both partial derivative of f exist. Means we have to check continuity and differentiability of this function and partial derivatives of this. So function is given by f of xy is given as xy upon mod x if x is not equal to 0 and 0 elsewhere. This one can be written as xy upon x if x is positive and xy upon minus x if x is less than 0 and 0 elsewhere. So x cancel out by this and this one. So we obtained y when x is positive minus y when x is less than 0 and 0 elsewhere. So this is our function xy. Now we have to check continuity of this function at 0, 0. So we have to check limit xy x comma y tending to 0, 0 of function. So as left hand limit or right hand limit we can check. So we have to check continuity of the function, so we can't approach as 0, 0 from all directions. So we can consider along the line y equal to mx. So y equal to mx is sufficiently many times we can check. So it can be limit x and mx tending to 0, 0 or finally x tending to 0 of f of xy. If x tending to 0, it doesn't mean x is greater than 0 or x is less than 0. So limiting value is 0. Similarly, when we will approach this point from right hand side or left hand side, so finally limit we have 0. Now we have to check partial derivative. Means function is continuous at 0, 0. We have to check partial derivatives of this. So f of fx at 0, 0. So it can be explained by limit h tends to 0 f of 0 plus h comma 0 minus of f 0, 0 divided by h, and this one can be written as limit h tends to 0 f of h comma 0 minus f 0, 0 divided by h. As h tending to 0, it means h is neither positive or negative. So by the structure of f, as we explained earlier, this is 0 minus 0 upon h. So 0. Never understand this as 0 by 0 format, because we obtained 0 by 0 format after putting the limit. But without applying the limit concept or taking the limit, we have 0. So final limit is 0. So fx exists. So fy 0, 0 will be limit k tends to 0 f of 0 comma 0 plus k minus f 0, 0 divided by k. Similarly, f0 k minus f of 0, 0 divided by k, and we have to find limit k tends to 0, and this one again k tending to 0 means x coordinate is 0. X coordinate is 0, so 0 minus 0 divided by k. So again we obtain the limit 0. Means partial derivative exists at 0, 0. Also function is continuous. So option B and D are true.